Good day to everyone. My name is Nkululeko, and in this session we will be looking at two things. We will go over two things. First is method construction in Java, mainly the components of a method header and what they do or allow you to do. And secondly, which is most importantly, the main purpose of this session, we will be looking at method overloading, right? Okay, so without wasting any more time, let's get back to it. Okay, so to explore like method construction in Java, we will be doing so by creating a program, a simple program where it prompts the user for input, name, which will be name and an age, right? And then that application will print it to the console that, hey, this person, or you are a minor or an adult or a senior, like a simple, not complicated program, just because we want to explore method construction, right? And this application will be called age group, hence the class. Okay, so before we start, let me just import a few things I will need. The scanner, import java.scanner. Yes, nice. Okay, the first method we will encounter, like any other Java application or program, is the main method, because your application will not run without a main method. So let me quickly declare that right now. So it's public static void name string. Okay, it's a string. Okay, we are done declaring the first method, which is the main method, of which is a requirement all applications have a main method, like I said. So now let's look at the method header and look at its components, right? Okay, so first I declared a access specifier, right? So an access specifier basically tells the application that, okay, this method can be accessed from anywhere in the application. In this case, if it's public, it can be accessed anywhere in the application. So I could have another class, I could make another class here that can invoke this method, right? But since this is just a simple application, we only have one class, so there's no need to call it. So we'll leave it at that. And by convention, it must be public because that would give access, that would give the JVM access to this method, so that when you're running it, the JVM can call it, right? Cool. Now let's look at the second keyword, the static modifier. Basically, the static modifier tells the application that, okay, this method can be called anywhere without creating objects. So this method is not dependent on any methods. It's not dependent on any methods. You can just invoke it, you can just call it, right? Cool. So let's look at the second keyword, void. This is the return type. So void returns nothing. It's telling you that, okay, this method isn't returning anything. You could have string, where your method will be returning string, but by convention, Java, or let me say the JVM, wants to see the main method as returning nothing. Hence why if you try to change the return type for the main method to string, it's gonna give you a problem. You can't run it anymore. Same with the method identifier, the method name. If I were to name it something else, let's say age group, it's gonna give me a problem. I can't run this because the JVM was told to look out for the method called main. So let me quickly say main. So now I can run it, right? See, I can press the play button. Even if I have main spelled differently as main uppercase M main, it has a problem. So Java is case sensitive, so it's looking for a lowercase method named main, right? And these are just the parameters. By convention as well, these are just how they are passed in. I'm sure we will get to work with this a bit more in the future, but for now, for the scope of this video, it's beyond the scope of this video, so we'll just leave it as that. Just know that for when you declare main methods, this is how it will always look, like this, right? Okay, cool. Now let's get into the actual code. So our program is supposed to prompt the user for their name and age. So let's quickly have our string. Let's declare a string variable called name, initialize it to nothing. Int variable called age, initialize it to nothing as well. Then let's create our scanner object, name it input equals to new scanner system. My PC is slow, bear with me please. Then we're gonna close that line. So now we have our scanner object, so let us prompt the user now. Let's say enter and just so the user enters it in the same line as the prompt itself, we just use print it on its own. Then we'll prompt the user again for the age, enter your age. I forgot to assign it. Say name equals to input that next line because we're expecting a string. Same for the prompt for your age. Age is equals to input dot next byte. Not let's make it a byte because we know someone's age cannot be that big, right? I've never heard of anyone who has lived to like 120 something years, right? So we just keep it as a byte because that's the limit. We are expecting like age values that are between like negative 128. I forget how big a byte is, but negative 128 and positive 127, I think. But that's besides the point. Okay, so now I have all my variables. I've declared my variables, and I have all my prompts. So let me just let me say input dot close my scanner here. Okay, now we are almost done with the main method because it's prompting everyone. It's prompting the user, right? Okay, so now let's make our method. And the first thing you have to ask yourself is, okay, is this method going to be accessed by is it going to be accessed by other classes outside of this class? If yes, then it's going to be public, right? Do I want it to be? Do I want it to be public? Is there any sensitive information? Is there any sensitive information it's dealing with? That's what you would ask yourself. But in this case, since it's a simple application, you can just leave it as public. But to demonstrate this, I can have it as private. It's static since it's not being called. It won't be called on any object. I want it to return a string because I want it to tell me the age group of the age group of the user based on their age, right? And the name will be get group. I'll pass in the integer called age, a parameter called age, and then I'll declare the method body. Okay, so its functionality is simple. We'll say if age is less than 18, right? Actually, let's say 19, because from 18, less than 18 included is still a minor, right? So let's just say that less than 19. If age is less than 19, return a minor. Close that statement. If age is greater than 18, because now we are accounting for adults, so between 18 and 65 if I'm not mistaken, and age less than 65. Yes. Okay, we're gonna return a string of an adult. Else we would want to return a string that says a senior, and that statement there. Okay, an error. Okay, no, that's not an error. Okay, so now our function is, our method is complete, right? It's private, and I named it private just to demonstrate that you can still use it even though it's private, because the private, the access specifier only tells it that how what permissions does the program have with this method. So if it's private, it can only be accessed within this class. Hence why I can have it as private and it won't have a problem. I could also have it as public if you wanted to. You could also have it as public. It doesn't matter. Static. It doesn't have objects, or it doesn't require objects to be invoked. It's returning a string. Its name is get group. Nice. Okay, so now let's actually use this method in our main method. So let's first declare a variable called string that will store our string that's returned by the method, right? Okay, we're gonna store it in a variable called age group, and then we're going to invoke the method get group, and then we're going to pass in age, and then we're going to use our semicolon. Okay, and then we can now print to the console a message. Okay, so let's say the user's name plus, so there'll be like someone, say hey, you are, and then concatenate the age group variable, and then we're going to close our scanner. So let's try running this simple program and see if it works. We'll wait for it to compile. It's gonna take a while, jeez. Okay, now it has prompted us to enter our name, age. Okay, I forgot to fix this as well. But for now, just to test it and see if it runs, we'll just enter the age over here, 20 years old. Ntuli, you are an adult, right? Okay, before we run this again, let me just fix this. Let's run it again. Okay. Age, let's say now I am 4 years old. Ntuli, you are a minor. Simple, right? Straightforward. Okay. Since we have gotten that out of the way now, we can now look at method overloading, which is the main purpose of this session, right? This video. Okay, so method overloading is when you create multiple methods with the same identifier, but you give those methods different parameters, right? So what that allows you to do is that it allows you to do the same thing but slightly different, right? So for example, if let's take a simple example like a greeting, you let's have a specific of greeting your friends, right? But if you wanted to change that such that when you're greeting your mentor or your teacher or someone who has like a higher title, you must be a bit more respectful or whatever, you would want to change that greeting to be like more suitable for that situation, right? So it's still a greeting, but you are just changing it ever so slightly such that it fits that situation according to that situation, right? So that's what method overloading is, and that's what it allows you to do. So we're going to explore that in a simple program that gives the user the total amount for the number of books they have bought and the discount, right? So let's get right to it. So this program will have 3 overloaded methods, right? The first one takes no parameters. The second one takes 1 integer parameter. The third one takes in 2 integer parameters, and all of them return doubles, right? Okay, so let's do that real quick just to create the headers and the empty body for the method. So we're going to create our public static double because we want to return a double, and total. In total, the first one will take in any parameters. The second one, same thing, static total, but this one takes in an integer and we'll call it books. Then
So your double total. This one's going to take in the parameters and have parameters of number of books and to make it a double or an integer. Let's make it a double for now because I want to demonstrate ambiguity later, right? So double say discount. So now we have our three overloaded methods, right? First one takes no argument, second one takes a argument, third one takes two arguments. So when no argument is passed to this method, it's supposed to return a double where I have a variable called total. Total is equals to the number, no, not the number, the amount for a book. So we don't have that right now, so let's just quickly create that. Since book prices will just keep them the same, they won't change, so we have them as final, meaning that this value should not change. And since we are creating this as like a global variable or a class variable, and we only have static methods, we should specify that this should be static and it's a integer. We are going to call it book price is going to be equals to 100 rand. Close that. Okay, so now let's get back to our method. So this just returns the amount of the book plus the VAT, which will be 8%, right? So that's going to be book price plus book price multiplied by 8% divided by 100. Close it there. Return total. We'll do the same for when we are passing in an argument, but this time to calculate our total, we're going to multiply the book price by the number of books plus the tax, right, which is 8%. So let's do that real quick. Double total equals to book price. Let's do it like this. Say book price multiplied by number of books plus book price multiplied by 8 over 100, which will be 8%. No turn total, right? That statement there. And the third one does a similar thing, but now we're going to have to calculate the total by the number of books and then add the tax, which is 8%, and minus the discount, right? So let's do that. Total equals to price multiplied by number of books plus the tax, which is 8%, minus the discount, right? And then we need to return total. Total is double. Oh no, my battery is low. Close that. That's really poor. Okay, return the total. Okay, so now we have everything. We have every overloaded method. So now we can prompt the user for the information. Of course, we're going to need the public. We're going to do it in public. Public static void main string args we're going to need, and for the number of books, let's say a byte books. We're not going to initialize it to anything. We're going to need an integer for the discount. I'm not going to initialize to anything as well. And we're going to do we need anything else? No. Okay, we're going to create a scanner. Now scanner in the input equals to new scanner system.in, and then we're going to prompt the user, enter number of books, and then number of books is equals to input.next byte, and prompt the user for the discount as well. Enter discount, and the discount is going to be equal to input next int. So now that we have prompted our user for everything, we can close our scanner object. Close. Then to demonstrate the capability of method overloading, we'll just print out we'll invoke all the methods so that you can see that the compiler is actually invoking a different method for each and every argument that you pass in. Okay, not each and every argument, according to the arguments you pass into the method, right? So we're going to say, since the methods are returning double, we have 3 double variables. Let's say total 1 is going to be equals to the method total, but we're not passing anything. The second one, total, and name it 2 is going to be equals to total, but we are passing in number of books, and then the last one, the third one, is going to be total 3, and it's going to be total, where we are passing in number of books and the discount, right? Okay, so let's now output to the console. Say let me just okay, yeah, no, that's not a problem. That's what I want to change actually. Yes, okay, so when no arguments are provided, let's say the total is that, okay, plus total 1, right? Because that's what is returned when no arguments are passed in. This variable, because we are assigning it to the method when no arguments are provided, so that value will equal to total 1. And then let's just do this, copy, paste it here. When one argument is provided, the total is change this to 2 paste. Actually, not one argument. Let's say when number of books is provided, yes, and when number of books and discount is provided. Let me change this as well. So this is going to output 3 statements which are when no arguments are provided, the total is whatever is returned by whatever is the value of the variable total 1. Same with the second statement, print statement, and the third one, right? Okay, so let us run it to see if it's successful or not. Fix anything if it's not. Wait. Okay, I'll fix that later. I just realized I'm not concatenating the right variable here. It's supposed to be 3. Let's just rerun this. So it's okay. Enter number of books. Let's say I want 3 books. What is your discount? Let's say discount is 20 bucks, 10 to 20 rands. So I have, when no arguments are provided, the total is 108 rand, because a book is equals to 100 rand, but then we are adding the 8% tag, VAT or tax, whatever you want to call it. When number of books is provided, the total is 308, because number of 100 rand multiplied number of books, and the tax to that, you get that value. Same when you have number of books and a discount. And the reason why it's not as much as 308 rand is because, remember, we are minusing the discount from that, right? So that demonstrates method overloading, because when these functions are called but they were provided with these arguments, the compiler knew which method to call. When no arguments are passed, the compiler invoked the first one. Invoked the first one, right? Same when 2 arguments are passed in, invoke the second one, the third one, right? So that is the gist of it, but there are some pitfalls or scenarios to watch out for, right? So in this scenario, we have 3 overloaded methods that take in no arguments. No arguments. Let me do this so it's more easily to see. It's more easier to see. Okay, so we have 3 overloaded methods. One takes no argument, the second takes 1 argument, the third takes 2 arguments. But we have to keep in mind that when your program is being compiled, the compiler will determine which method to run. And the way it does that is that it uses the arguments, right?
And this brings us to ambiguity, where if you provide overloaded methods that the compiler cannot tell the difference, because the compiler is using the parameters of the method, right? So if I were to have another method called public static double total, and I have an int called let's say what do you call it, let's call it var, and then a double called rate this time, and inside this method I'm calculating the total in a or at least I'm expecting to calculate it in a different way than this method, right? But the problem is that the compiler won't know which method to run between the two of these, right? Because they both have parameters of int and double in that sequence. So when your compiler is running, it'll just take the first one. So it'll just run it'll just run the first one it encounters, of which that would be a problem, where when you're expecting the functionality of this method to be applied when you are passing in an argument of integer and double, but then you find that the functionality of this method is being applied instead of this one. And that's what ambiguity is. The compiler doesn't know which method to run, because the things that it uses to identify which method to run are the same. So how you would get around this is that you'd have to have like different number of parameters, or the order should be different. So if I were to say double, the parameters are a double called rate and a integer called it's outside, integer called var, right? Then this would work, because now, although I'm still passing in a double, an integer and a double, the sequence does matter. The sequence does matter. So although it's passing in the same parameters as the third argument, as the third parameter, as the third method, sorry, but since the order is different, then it qualifies as a legal overloaded method, right? So yeah, this brings us to the end of this session, where we were covering methods and method overloading. So yeah, it is a nice feature to know and take advantage of. Right now it doesn't seem as important, because we're just using it in like simple programs where you might think of a more quick way or straightforward way of just going around this. But once we get to work with more complicated applications, where maybe we are dealing with a method that's like really complex and it's not as easy to like take the shortcut, method overloading would make that task much easier, right? So yeah.